The data node acts as the holder of the data, and the name node at regular intervals will send the statistics to secondary name node in something called a journal or FS image, right? But if in Hadoop 1 name node dies, everything is gone. The administrator has to manually go to the secondary name node, take the journal and FS image, reload back it into the name node, and do all kinds of stuff, right? So Hadoop 1, as you know, they got released in 2008. All the different companies started using it in production ready applications. And then started the problem. Always the first version is like that, right? Bugs, bugs, bugs. But more than a bug, what they have seen is when the number of nodes, typically it will not come for any of us, but in high, large, big production companies like eBay, Yahoo, etc., when the number of nodes was increasing beyond 4,000, that means 4,000 nodes, and running concurrent MapReduce jobs, Hadoop 1 became a big failure. It was not able to sustain the full load. And the people started thinking, where is the problem? The problem is, let us look at these daemon processes. All these are called daemon processes. A daemon process in Unix is nothing but always running process. So all these are daemons. And let us just look at this guy who seems to be the biggest problem. In Hadoop 1, tell me, what is the responsibility of job tracker? When I write the MapReduce program, the job tracker takes the code, distribute it into each and every node where the data is, correct? And then starts a task. A task can be either a map or a reduce. So the job tracker is running the tasks. Who is responsible for checking whether the task is running or not, and if task is not running in one node, contact the name node, ask where is the duplicate copy, and then find out where the copy is, and then restart that job. And if then the old job is coming up, then decide which one is acting speculative execution, right? Job tracker only. Name node is not coming into picture. Job tracker is the executor, right? So job tracker is doing all that work. Next, who distributed the job and who is keeping track of the aggregation of the results and making sure that everything is running perfectly? Job tracker. Who is sending a keep alive signal to each and every data node or task trackers and then getting the response, making the handshaking with all the task trackers? Job tracker. Obviously, the Hadoop architects understood that the problem is job tracker because it is overloaded. It has got not one responsibility, it has got many things to do. And when it is exceeding 4,000 nodes and the concurrent jobs are increasing, it became very difficult for the job tracker to scale because job tracker is a daemon process and it is only one in the entire Hadoop cluster. Task trackers are many, data nodes are many, but your name node and job tracker only singular. So the moment job tracker became the responsible, there is no problem with the name node though. Why? Name node is just distributing the data before your MapReduce is even running, correct? So name node could distribute it and name node could scale well, but the same could not be applied to a job tracker. So the Hortonworks team, mainly led by Arun Murthy, they started revamping Hadoop 1, telling that I need to segregate the responsibilities of job tracker. Typically, in programming, when many things are combined together into a particular component, the methodology they adopt to make it scalable is take out each responsibility and create, instead of one person, three persons to do that job, just like a practical life. So, the job tracker is creating the bottleneck. Let us create somebody else as well and then dilute the work of job tracker into one or more persons so that it has got now the seamless capability to scale. So they revamped. So from anybody is asking you what are the daemon processes in Hadoop, forget about this and never tell it. It is wrong because it is no more there. The reason why we learned all these things is to just tell you all the concepts in a detailed manner. So job tracker and task trackers are no more existing. And there is one more issue here. Let us assume that in the practical world, Shashi is one node and assume that this node is having 64 gigabytes of RAM. And Mahesh, let us assume that unfortunately it is an 8 GB RAM, that node. Now the job tracker is running the word count. Will it make any distinguishing difference between Shashi and Mahesh? No, it will just submit the job. But ideally, since Shashi has got 64 GB of RAM, she should be able to do more jobs than Mahesh, correct? So the CPU, the memory, the ability to utilize the resources effectively is not done in the old architecture. So they all thought, let us bring in a new person and we will call it as yet another resource negotiator. We are going to bring a new person. What is the name? Yet another resource negotiator. And what is the responsibility of this guy? This guy will decide, hey, if Shashi is running 100 jobs and if a new job is coming, should I give to Shashi or should I select Mahesh or should I select Vasavi, right? So that negotiator will negotiate with the resources based upon the CPU, based upon the memory. It will decide whether you are capable of running the job or not. And let us take the first letter of this YARN and the new architecture which is based on Hadoop 2 is called YARN. YARN stands for yet another resource negotiator. And what is there inside YARN? So what are the people replacing job tracker and task tracker? YARN has introduced new concepts and entirely new architecture. We can confidently say that it is because of YARN that Hadoop became so famous. Had they not been changed, the architecture from here to YARN, Hadoop might not have become this much famous. And today, Hadoop is in production for let's say 10,000s of companies, is because of Yarn. Because now you can scale it into 40,000 nodes, 60,000 nodes without any problem. And the trick they have done is divided the responsibilities effectively. Next important thing that they have done is, if I am giving you a PowerPoint application, what you can do with that PowerPoint? Only you can create PowerPoint presentations, right? Because PowerPoint is an application meant for creating PowerPoint applications. This was like this. And the MapReduce was the only type of application that you can build on this particular architecture. And we wrote only MapReduce. MapReduce is the only type of application like PowerPoint. So I gave you a PowerPoint. You cannot do anything other than PowerPoint. I cannot create a PDF, for example. I cannot, let's say, draw a VCO diagram, for example. I can do it only for that specific purpose. That was the drawback of Hadoop 1.0. Now, think differently. I'm not going to give you a PowerPoint. I'm going to give you an operating system like Windows or Mac. Now tell me what you can do. You can install PowerPoint, you can install Word, you can install PDF writer, you can install Visio, you can install whatever you want. So, MapReduce became one type of application, and you can build so many other applications also on the top of Yarn. So, Yarn extended the capability, and MapReduce became one of the many programming things that you can do on Hadoop 2.x. Right? So, that is what Yarn has brought in. And now you will ask me, tell me another application that you can write on the top of Yarn other than MapReduce. I can create a MapReduce in a different way without using the local file system, by using only memory. It's a different MapReduce, right? Today our MapReduce is using completely the file system and all, and it has got MapReduce, all these particular architectures inbuilt into that. I can write MapReduce which is completely writing on memory, and they called it as what? Spark. I can write a graph-based application. They called it as Giraffe. I can write another application to query my databases on the top of Yarn. They call it as Tez, T-E-Z, Tez. Hortonworks is providing you. Yarn became super hit because now you can build so many applications on that. So the answer, Spark runs on what? Yarn. And it is because of Yarn that Spark is gaining popularity. And that is the reason why, if there is an HDP Hortonworks platform, you can install Spark on the top of it, because it uses Yarn. And all of the HDP architectures or Clouder architectures is, if you type Hadoop version, what is the answer that you are getting? 2.6 point something something something, which means that it is not Hadoop 1.x, it is Hadoop 2.x. You can easily see it, and that is the first command that we have typed. So if you look at that and then type Hadoop version, you will clearly see the message that is coming, that it is a version which is on 2.6 is the version that you will see there, right? So you can see that it is 2.6. What is it? Yeah. So Hadoop 2.6.0, which is the 2.x version, right? And when you look at 8088, it is the Yarn's execution engine that you are seeing. So all these days, whenever you are configuring or logging into 8088, it was Yarn. Do you know what was the port for Hadoop 1.x? There was no 8088. 8088 came from Yarn onwards, Hadoop 2 onwards. It was 570 and 530. We never used 530. Why? We got replaced. It got replaced. Now 530 will not give you anything. 8088 will give you. Why? Because everything is changed into Yarn. And there are some amazing things that you can do, but it is beyond your beyond the scope of this course. But let me just mention to you what it can do. Towards the last, I will tell you. So that is what is there in the material 2, which is available on Piazza. You can just go through that. There are so much APIs and everything is available inside that. Leave about the APIs and all. And I have clearly distinguished the difference between 1 and 2. Now, what is the internal architecture of Yarn? And I told you, right, the job tracker is divided into one or more persons. Who are that one or more persons? One is a resource manager. So, resource manager. Second, a node manager. Please see, there is no job tracker, there is no task tracker. Then there is an application master. Then there is a scheduler. Don't write, it's there in the PowerPoint. And then there are containers. See, one job. This was what it was done by job tracker earlier. And no doubt, it didn't scale. But now you divided it. And later they came to know, after they write that, in the original GFS paper, original Google paper, all these things were mentioned. But they didn't implement it in the first phase. So you think about those guys. They implemented the very first time the right way. Now we have got all these things. Now let me show you the flow. The word count application is coming. Okay? The scheduler will schedule the job first thing. Because in the job will be having so many jobs are coming from so many people, right? I have submitted one, Vasavi submitted one, Bibin submitted one, so many jobs are there. The scheduler will use a fair scheduler internally and then will schedule the job. The resource manager will look who is capable and how many data nodes I have. So I have 100 data nodes. My data is divided, right? Twinkle, twinkle, little star on one, next line on another, next line on another. The data is divided, right? And there is 3 copies, correct? Out of that, who is capable? Look at that. Resource manager is deciding now. Otherwise, as I mentioned to you, one may be having 8 GB RAM, one may be having 64 GB RAM, and that 8 GB RAM is already running 2 programs given by Vasavi, and if I am giving a word count, it doesn't have the capacity to run. Resource manager will allocate. Which node manager should be responsible for running the process on nodes? So assume that resource manager decided Shashi, Bipin and Mahesh are going to run it. Now what is going to happen? Resource manager will tell, okay, these 3 people are going to have a manager. Every code will have a manager, every application. So if I run an application, the resource manager will allocate one manager for me. If Mahesh is submitting an application, MapReduce code, then Mahesh will get another manager.
Dynamically created.
Yeah. Every application that resource manager is identifying, it will create a manager, and the name of that manager is application master.
So the manager will be one of the 3, or it will be outside?
Yeah, it can be outside or it can be one of you.
Okay.
It will be one node. So, pardon?
Nodes will act as manager.
Correct. So, application master has created. For which program? My word count program. Now, what the application master will do? Application master is going to start containers. Container is assumed like a bucket. For the nodes that is being selected by resource manager. The containers is now going to execute the job. Every application will have a job ID and an application ID. And now do you recollect that whenever you run the program, application ID equal to container instantiated, all that messages are coming when you run the MapReduce program? That's the reason. So resource manager, application master, node managers, containers, all these things work in unison to get the relevant output in a highly scalable manner. Remember, you cannot see application master and containers because that is used internally when you run the code. But what you should see, resource manager and node manager. So if suppose you are going back to your Hadoop architecture and then if you type sudo jps, you will see, okay, so many things are there. Look at that. A resource manager is there and there is a node manager, then there is a data node, and then there is a name node. Must be there, name node. Is there a job tracker? No. Is there a task tracker? No. It won't be there. Now another beautiful factor. In Hadoop 2, secondary name node is an active backup node, which means that you don't have all the problems that I told you, that loading manually and all those things. The moment the primary name node goes, the secondary name node will take into effect. And they created one more backup node, like old secondary name node. If that is also going, then do the manual thing.
So one quick question, Ravi. So you said container, right? Is it that container or it's a node?
It's a node. It's a node. Everything is a node. It's a node manager. Everything.
Okay.
Right? Container is nothing but the JVM in which your map and reduce are working. That's all. The behind thing is that it is a JVM, Java Virtual Machine. Clear? Now, what is the advantage of Yarn? What advanced programmers are doing? Let us assume that you have an ab initio job which is taking 8 hours. What you can do now, take that ab initio job and yarnize it so that now that ab initio job will run on Yarn by utilizing all your clusters and will give you fast result. It will never fail. It will allocate resources dynamically and will get beautiful outputs. All monolithic applications which were taking time can be yarnized by a very advanced coding. So 2 days back, the manager is getting the update from one of our data lineage guys. Hey, Informatica needs Apache slider. Apache slider is not there, so I am just hearing it. What is Apache slider? Apache slider and Apache twill, TWILL, Apache slider and Apache twill. And if you look at the Google and you go to google.com and then just type Apache slider, google.com, and then type Apache slider and then press enter and then click on that. As the heading indicates, it will help you to yarnize your application, right? Very advanced coding. So why this guy was telling Informatica what they did? They have created their code and yarnized it using Apache slider, and that is why these people are trying for installing Hadoop, installing this, installing that, installing everything. That is the internals. So they had the code earlier which was not Hadoop operated, which was taking time, which was taking time consuming things, which will fail. And what they did? Just used Apache slider and yarnized it, and that's why you need to install Apache slider. Similarly, there is Apache twill. Any complex process can be yarnized, right? So that's about yarn. So always remember that Hadoop 2 uses yarn. Yarn stands for yet another resource negotiator. It has got resource manager, node manager primarily, and the remaining all are internals. Just for your understanding, I told you. If you want to see the diagrammatic representation of how these things are working, it's a very time consuming slide, but I will just show you. And the PDF copy is already there in Piazza, which is the part 2 material. So let me just see whether it is there or not. Yeah. So I'm going to connect to my other